Assalamu alaikum, dear students. Welcome to lecture number 7 of Geotechnical Engineering 1. Today we are going to discuss unit weights and specific gravity of soils. Okay, so moving on. First of all, unit weight. Unit weight of soil or unit weight of any material is defined as simply how much weight of soil or weight of that particular material can be put in a unit volume. Okay, whatever your units are, for example, if you are using SI units, your units of the volume will be cubic meter. Okay, so how much kilonewton of a material you put in 1 cubic meter, that will be the unit weight in kilonewton for that material or soil. If you are using MKS system, then in MKS system for weight we use the unit as kilogram, and for the volume we use the unit of cubic meter. Okay, so in 1 cubic meter, how many kgs of material you put, that will be the unit weight of that material. For example, in case of water, we can put 1000 kg in 1 cubic meter. Okay, so an MKS unit, the unit weight of water will be 1000 kilogram per cubic meter. Okay, or if we are discussing the CGS system, then in CGS system the unit for the volume is cubic centimeter. Okay, and for the weight it is gram. So how many gram of materials we can put in 1 cubic centimeter, that will be the unit weight of that material or soil in this case, because soil is our objective over here in this subject. So the unit weight will be basically simply the weight of that material divided by the volume for which you have taken the weight. Okay, and that will give you the weight of that material which you can put in 1 cc or 1 cubic meter, or if you are using FPS system, then in 1 cubic feet of any material. Okay, so that is basically how we define the unit weight. So in case of soil, as we know that the soil has void spaces in between them. Okay, between the particles there are open voids, and these voids may be under different saturation ratio. Okay, they may be fully saturated voids or partially saturated voids, or voids with very little amount of water. Now if the voids are filled with water, because water obviously does have weight, so the total weight will be equal to the weight of particles plus weight of water. Okay, so in this case the unit weight of the soil will be more, because weight divided by volume, the volume is same but the weight is more because of more water. Here you can see that the amount of water is reduced. Now the air does not have any weight, it has a volume but it does not have any weight. So that's why in this case the unit weight will be slightly less compared to that one. And in third case you can see the water amount is further reduced. So the weight will be further reduced but the volume is same. So weight divided by volume, then the unit weight will be further reduced. Okay, so that's why we need to understand that unit weight of the soil will be different in different moisture content. Okay, or in different saturation state of the soil. We will discuss in detail later on about saturation ratio as well, but just to tell you that saturation ratio is basically a ratio which tells you that how much amount of voids are filled with water. Okay, is it 100% voids are filled with water, 50% or 0%? Okay, so if 100% voids are filled with water or moisture, then it will be 100% saturated soil. Okay, if there is no water in the voids, then it will be a dry soil and the saturation ratio will be equal to 0. Okay, so based on the amount of moisture, the soil unit weight is classified in the following types: bulk unit weight, dry unit weight, saturated unit weight, and submerged or buoyant unit weight. So we have 4 different types of unit weight based on the amount of saturation of the voids of soil. Now first discussing the bulk or total unit weight as well. It is represented with gamma or sometimes gamma T, while T represents total, gamma represents the unit weight in most of the books. So bulk unit weight is equal to the total mass including moisture, natural moisture which we have in a soil, divided by the total volume. It is also known as a total unit weight as well. So in natural form, when you take soil, you see it has some amount of moisture. It is not completely dry, but most of the time it is not completely saturated as well. So it is in intermediate condition usually between the fully saturated and between fully dry soil. Okay, so in that condition, if we take soil and take its weight and divide it by its volume, then that will be the bulk unit weight or the total unit weight. So the bulk unit weight will be equal to the weight of soil mass with natural moisture content divided by the volume of that soil mass. Later on, we will discuss in the lab, we will perform some experiments in which we will actually be determining those different types of moisture contents or the unit weights of our soils. Okay, so that will be that part will be covered in the lab. Then we have dry unit weight, and it is represented with gamma D. Now, as the name indicates, in this case the soil is dry. So if you keep the soil in oven, commonly how we dry the soil in the laboratory setting, we just put it in oven and heat it at 110 degrees centigrade for 24 hours. Okay, in airtight oven, that sample is considered to be fully dry. But in natural form, sometimes the exposed soils in the arid regions, they can also be in dry form as well. Okay, where in the areas where there are less rainfall, and there is more sun in arid regions, then you may have a dry soil as well over there. So if you take the weight of dry soil or the weight of only solids, because obviously if the voids are empty, if there are no water moisture in the voids, then the voids will be completely empty and it will have only solids, okay, soil particles. So that's why it is also known as weight of solids as well. So weight of dry soil or weight of solids divided by the volume of that soil will give you the dry unit weight. So dry unit weight in equation form can be written as weight of the solids divided by the volume. Okay, so weight of the dry soils or weight of the soil solids divided by the volume. Next is saturated unit weight. So it is represented as gamma sat, SAT for saturated, gamma for the unit weight. Now, as the name indicates over here, on the contrary to the dry unit weight, over here all the voids are completely filled with moisture. So then the soil is known as fully saturated soil. Now commonly when you take soil in the areas where water table is high, like Warsak Road, Shami Road area in Peshawar, where water table is high, if you take a soil, you see it is usually completely filled, its void is usually filled with water, it is fully soaked soil, so that soil is insaturated. Commonly if you take any soil sample in Sarhad University, in your lawn, etc., then that its weight will be bulk unit weight. It will not be fully saturated because that soil is not fully saturated, because the water table is not in the reach and the soil is commonly in the intermediate condition between fully saturated and between fully dry. So but if you take a soil sample from below water table or on the Warsak Road, Shami Road, where the water table is high and the soil will be usually fully saturated, all the voids will be filled with the water. So weight of that soil divided by the volume of that soil will give you the saturated unit weight. So that in that case, the unit weight is weight of the soil in saturated form divided by the volume of that soil. The last one, fourth one, submerged unit weight. Now, submerged unit weight is similar to saturated unit weight in a sense that all the voids will be filled with water. Okay, but also if the soil is below water table, then water applies a buoyancy force on anything. If you immerse anything in water, it will displace the water, and because of that displacement, the water will apply the upward force on that object, and this is how the ship sails in the sea. Okay, because they are displacing a large volume of water, and the upward force which should be applying on the hull of those ships should be equal to the volume of water they displace. Now remember, 1 cubic meter of water is weighing 1000 kilogram. Okay, so if you displace 1 cubic meter of water, you will get a force equal to 1000 kilogram in return as a buoyancy force. Okay, now when this force is acting in upward direction, because we are talking about unit weights, and weight is mass times gravity, which is gravity is acting in downward direction, so weight will be usually acting in downward direction, but you have buoyancy force from water in upward direction. So the net unit weight will be the submerged unit weight, which will be the downward weight, which is gamma sat, because the soil is also fully saturated if it is below water table, minus the upward force which is applied by the water in this case, which is gamma w. Okay, so the net unit weight will be equal to gamma prime, which will be equal to gamma sat minus gamma w. Gamma w is the unit weight of water, which in SI units is 9.81 kilonewton per cubic meter. In CGS system, the unit weight of water is 1 gram per cc. And okay, so whichever system you are using, a system of units, you will basically determine the effective unit weight or submerged unit weight by subtracting unit weight of water from the saturated unit weight of that particular soil. Now, moving forward to specific gravity. Specific gravity is also very important property when it comes to defining the properties of soil and classifying them into different groups. Specific gravity is defined as ratio of unit weight of a material for which you are determining the specific gravity divided by the unit weight of reference substance. The reference substance we take in this case is water at 4 degrees centigrade, because the water is in densest form at 4 degrees centigrade. At different temperatures, at higher temperatures, the density of water will be less. So we want to standardize it. So that's why we will be taking it as a reference substance, and the unit weight of water will be taking as unit weight of water at 4 degrees centigrade, which once again is equal to 9.81 kilonewton per cubic meter, an SI system, or 32.2 pounds per cubic feet in the FPS system. So if you take a unit weight of any substance and divide it by the unit weight of water, you will get the specific gravity. Because this is a ratio of specific unit weights, so the specific gravity is a unitless quantity. Okay, there is no units of specific gravity. So if the specific gravity of any object, any material is less than 1, what does it mean? It means that the value of numerator is less than denominator. Okay, it automatically means that the density of that substance is less than density of water. So if its density is less than water, then water will be heavier than that object, and that object, if you put it in water, it will be floating on the top. Similarly, if the density of substance is greater than density of water, then the value of specific gravity will be greater than 1. So, which means that that object will be heavier than the water. So, specific gravity can tell us that how much heavier a particular substance is in comparison to the reference subject, the reference object over here, which is water. The unit weight of water is usually constant. So from that we can get indication that any object under the study is heavier or lighter than the water, or if it is heavier, then on the scale of water how much heavier it is. Okay, so if one a substance has a specific gravity of 2.5, another has a specific gravity of 3, so we will automatically know that the substance with specific gravity of 3 is heavier than the 2.5 one. Okay, here is the specific gravity of various substances. Like wood has a specific gravity of 0.6. That's why when you put wood in water, it floats on the top because it's lighter. Ethanol or petrol or other fuels, you know, their specific gravity is also less than the water. So that's why when you put oil in water, it floats on the top because specific gravity is less. Specific gravity of water is obviously equal to 1. Okay, because the reference substance is water. Water divided by water will give you 1. And in iron-rich soils, which are heavier soils, the specific gravity is up to 2.82, and in case of cement, it is up to 3.15. So specific gravity is a very important scale which can tell you about the unit weight of any materials as well. If you multiply specific gravity by the unit weight of water, which is 9.81 in SI system. So if you have specific gravity of any item, any substance given as 2. So 2 multiplied by 9.81, so that will basically gives you some 19.62. So 19.62 will be the unit weight of that material, 19.62 kilonewton per cubic meter. So if you have the unit weight, then you can basically specific gravity, then you can basically determine the unit weight as well, okay, of that particular substance. Okay. Now specific gravity of soil solids. For soils, the substance is usually replaced by the soil solids. Okay. When we take the specific gravity of soils, we take specific gravity of solid particles only. Okay. So specific gravity of soil solids, or GS, is represented as density of soil solids divided by the density of water at 4 degrees centigrade. So unit weight of soil solids, if you divide it by unit weight of water, then you will basically get the specific gravity of soil. And that's why, because of its specific gravity of soil solids, we represent it by GS. G for specific gravity and S for the solids. So the coarse grained soils, which will have more voids and less particles, hence they will have smaller specific gravity because there is a lot of void space open in there. So in given volume, in equal volume, you will have less weight of solids. Okay, in comparison to the fine grained soils, like I've compared gravel with sands over here, and you can see the amount of voids in case of sand is less, the amount of voids in case of gravel is more. So the gravels have lower specific gravity and sands will have higher specific gravity, up to 2.8. So usually for the soils it varies between 2.65 to 2.8, which can tell us on a relative scale how much one material is heavier than another. So in this table, some common minerals are provided and they with their specific gravity, like quartz, kaolinite, elite, montmorillonite, halloysite, potassium feldspar, sodium and calcium feldspar, chlorite, biotite, muscovite, etc. So you can see over here clearly which minerals are heavy and which are light. If you know the specific gravity, you can clearly tell over here that kaolinite is lighter than quartz. Okay. Similarly, kaolinite is lighter than elite as well. Elite and kaolinite, they are both types of soil, mineral forms of clay soils, and you can see that elite clay soils will be heavier than kaolinite clay soils, because kaolinite clay soils usually have more void spaces compared to alite, so that's why they will be lighter compared to the alite soils. So just by looking at the specific gravity, you can basically tell that a particular type of the soil, it is heavier or lighter in comparison to the another. Okay? And you can see over here some of the minerals like olivine has a specific gravity of 3.27 to 3.7, which means they are very very heavy compared to those soils. And similarly, the specific gravity of mercury is the highest, which is 13.6. So which basically tells you that the mercury is 13.6 times heavier than water. So it's good to have that reference compared to water. So if I tell you something is 13.6 times heavier than the water, then you can easily imagine if it is heavier or lighter. But if I tell you that something is heavier 5 times of petrol, then probably you will have hard time realizing that how much heavier is 1 liter of petrol. Okay, so that's why specific gravity is very important property, and we will be also using this property to determine various other properties like void ratio, saturation ratio, etc. In the coming lectures. So do realize to revise specific gravity before we are working on the relationship between various properties of the soils, which will be coming in the next week. Okay, so thank you very much for listening. Should you have any question, you can leave in the discussion section on the portal. Thank you very much for listening. Good luck.